Alright everyone, so today we're going to be talking about projectile motion, which is the last part of kinematics for AP Physics C. Okay, so let's look at this first example. A ball of mass 0.4 kilograms is launched horizontally from the top of a cliff 80 meters high with the speed of 20 meters per second. What is the horizontal distance traveled by the ball right before it strikes the ground? Okay, so what we want to do is we want to figure out what this is, this horizontal distance. What I like to do for the projectile motion problems is I want to break down everything into its x and y components. So let's list everything we know. What we should know is acceleration to x is never accelerates in the x direction, so it's just 0. Gravity is the only thing acting on it, so acceleration to y, I'm going to put negative 10. You can put negative 9.8 if you want. And then what else do we know? We know that we're throwing this thing horizontally, so that means it's going to be going 20 meters per second at the beginning. And initially in the y direction, actually, since it's just thrown horizontally, the initial velocity in the y direction is actually 0. Next thing we know is this ball is going to be falling down 80 meters. So I'm going to put negative 80 meters in the y direction, and we don't know what things are in the x direction. This is actually what we want to find out. So remember, you need 3 pieces of information in order to solve for a problem, and we only have 3 pieces of information in the y direction. So one thing we can find in the y direction that's the same in both the y and the x is time. So let's find what this time is going to be. So I'm going to use the formula displacement of the y equals v initial y t plus 1/2 at squared. Displacement y is negative 80 is equal to 0 plus 1/2 negative 10 t squared. So then let me see, 160 divided by 10, 16 divided by t. T is equal to 4 seconds. So now I know there's 4 seconds. And now let's figure out this displacement x, what we're looking for. Displacement x equals v initial xt plus 1/2 at squared. And we have displacement is equal to v initial, which is 20, t, which is 4, plus 1/2 a, which is 0, 4 squared. So this all goes to 0. So then we have 80 meters. Nice. All right, let's look at the next problem. Okay, let's look at example 40. The speed of the ball just before hitting the ground for the picture below is blank. So one thing that we should know is in the x direction, there's no acceleration. So in the x direction, the velocity is always going to remain the same. In this case, it's 20 meters per second since it's launched out horizontally. However, in the y direction, what we should know is it's going to be getting faster and faster and faster and faster. So let's figure out what this is going to be. So in the y direction, let's figure out what this final velocity is in the y direction. We know the initial velocity in the y is 0 because it's thrown horizontally. Acceleration in the y, negative 10. Displacement in the y, negative 80. So let's figure out what this v final in the y is. So v final y squared is equal to v initial y squared plus 2a change in y. So this is going to be vfy squared, which we're looking for, is equal to 0 plus 2a negative 10, displacement y negative 80. So it's going to be 800 times 2, 1,600. We know what that is. Well, let's just put in the calculator anyway, 40 meters per second. What I should know is this is squared, so it could be plus or minus, but we know it's going to be going down 40 meters per second. So 40. But this isn't the answer, okay? So don't put 40 and don't put 20. We have to do the Pythagorean theorem now. So we have 20 going to the right and 40 going down. And now we can use Pythagorean theorem to figure out what this velocity is. This final velocity. So I'm going to be doing 40 squared plus 20 squared, square root of that, and I get 44.72. 44.72 meters per second. Okay. D. All right, moving on. All right, which graph represents the vertical speed in the y direction of the ball from the moment it's released until just before the ball hits the ground for the drawing below? So again, we see that it's launched horizontally. We're seeing everything that's launched horizontally at the beginning. What we should know is that if it's launched horizontally, the initial velocity in the y direction is going to be 0. And as it goes, it's going to be 0. And then as it travels further and further, the y direction is going to get faster and faster and faster. Okay? So let's look at this. Where does it show that? This is the only one that shows that it starts with initial velocity of 0. I guess this one does too. However, we know that it's going to be getting faster and faster with a constant velocity, or I mean, it's going to be a constant acceleration of -10. Okay, so we know the velocity in the y is going to be increasing by 10 meters per second squared. This one shows an exponential growth, not a constant acceleration, so it can't be that. And everything else doesn't begin at 0, so it's going to be this a. Okay. All right. Let's look at the next example. A ball follows a parabolic path shown in the figure, which best indicates the direction of the velocity, if any, at point B. So we see point B is at the very top here. And a lot of times people think, oh, at the very top, the velocity must be equal to 0. However, that's not the case. At the very top in projectile motion, the velocity in the y direction is 0, but the velocity in the x direction remains constant all the time. Remember that. So how is it going to look? It's going to look like A. Okay, let's look at conceptual question number 14. A golf ball is hit on level ground. The ball is hit at an angle of 60 degrees. At what other angle can the ball be struck at the same velocity and land at the same spot? Okay, so we see, let's just draw level ground. Level ground. And then we see 60 degrees like this. At this point, we know it's going to travel something like that. What we should also know is that there's a few ways to think about this, but the other angle that it's going to be going this way is going to be at 30 degrees. So 30 degrees, it's also going to be landing at the same spot. How we could think about this is we know the furthest it's ever going to go is at a 45-degree angle, and whatever goes above that, so in this case, if you go 15 above, which would make 60 degrees, and 15 below, which would make 30 degrees, it's going to reach the same spot. Okay? Another way you could think about it is the two angles should add up to each other. So 60 plus 30 is equal to 90. 20 and 70 will land in the same spot, which also equals 90. 10 plus 80 also will land in the same spot, 90. So just know that. But that's how you can think about this. All right. Example 42. A toy rocket reaches a height of 72.3 meters and lands 111 meters from the launch point. What was the angle of launch? Okay, very good. So we have this toy thing. We see that reaches a height of 72.3, okay? And then it also goes 111 meters from where it was launched. So we want to find what is this angle here. Okay, so let's see what we know. We know x and y. I always start with acceleration because it's always the same. Acceleration x is 0. Acceleration y, as long as we're on Earth, is negative 10 meters per second squared. What I also know in the y direction is the highest point it reaches is 72.3. Well, is that what I want to do? I guess so. Okay, 72.3 meters. What I also know is when it reaches that highest point, I know that that velocity, I'm going to call it v final, in the y is equal to 0. Okay? Now let's look at the x. At the x, I know that the displacement of the x is equal to 111 meters. Anything else I know about the x? 72, 111, acceleration of x is 0. I guess not really. That's all I know for the x. Okay, so let's try to solve this. So the first thing, how I'm going to try to solve this is, we're trying to find what this angle is, right? What I'm going to try to do is I'm going to try to find what the initial velocity is in the x, and then what the initial velocity is in the y direction. So let me find out first what the initial velocity is in the y direction. I'm going to use this formula, vfy squared is equal to v initial y squared plus 2a change in y. 0 is equal to v initial y squared plus 2 negative 10 change in y 72.3. So then I get v initial y is equal to, let me put this in my calculator. 72.3 times 10 times 2 square root 38.03 meters per second. So I can see this is 38.03 meters per second. But now I still have to find what v initial x is. The problem is I only have 2 pieces of information here. So I need one more piece of information in order to help me find this. So what I'm going to do is I'm going to try to first figure out what time is on the y-axis. So then that'll give me more information. Let me figure that out up here. So I know in the y direction, I'm going to say displacement in the y is equal to v initial y t plus 1/2 ay t squared. There's a few things I could do. I could find what the time is of how long it takes to get to the 72.3 mark, or I could find out how long the time takes to get back over here. And what I'm gonna do is I'm gonna find what the time is to take all the way over here. So I know at that point the displacement in the y is 0 because it started at this height and it ended at the same height. So displacement in the y is 0. V initial y, we found that's 38.03. Time, that's what we're looking for, plus 1/2 -10 t squared. So let's put this on the side. Negative 38.03 is equal to -5 t squared. Oops, there's a t over here. Let's divide both sides by -5 t. And then I get t is equal to, oh, this is getting a little floppy. Divided by 5. 7.61. Okay. So now, when I'm doing this, I could find what the v initial is in the x direction. Let me go over here for that. Displacement of x equals v initial x t plus 1/2 ax t squared. 111 is equal to v initial x 7.61 plus 1/2 0, 7.61 squared. This all goes to 0. Then I get v initial x is equal to, can you guys hear the baby in the background screaming? My wife is trying to calm him down. Don't worry, I'm not neglecting him. So hopefully things are better. 14.59 meters per second. Okay, so I know that this is now equal to 14.59. And then now I can use tangent to figure out what this angle is. Oh wow, this whole paper is getting rid of. Tangent 38.03 all over 14.59. And this is equal to the angle of, let me just put this in, tan 38.03 divided by 14.59. And you get 69 degrees. Okay? 2b. All right, so now let's look at this next problem, number 43. A ball is thrown at an angle of 60 degrees. If the ball is thrown from a height of 2 meters above the ground with a speed of 20 meters per second, how long is the ball in the air? Okay, so let's draw this out. So we see this ball 2 meters above the ground. All right. Ball is thrown at an angle of 60 degrees. Okay. It's thrown with 20 meters per second. And we want to find out how long is it in the air. Ooh. I can already see this problem already. So this one's going to be a bit difficult. All right. X, Y. What do we know? We know that the actually, like I said, I like to start with acceleration. Acceleration at x 0, acceleration y -10. What else do I know? I know it's going to be falling down 2 meters, so -2 meters. And then I can figure out what the x and the y is. So I know the vy initial is going to be 20.5. Oh, this isn't a half. This is going to be half. So this is going to be 10 meters per second here. So v initial x is 10 meters per second. But v initial y, let me see what that is. 20 times sine of 60. And that's going to give me 17.32. So v initial y equals 17.32 meters per second. And that's the last thing, so we have to find time here. All right, so let me draw this out. What I know, displacement in the y is equal to v initial y t plus 1/2 ay t squared. -2 is equal to 17.32 times t plus 1/2 -10 t squared. What you should know at this point is that this is a quadratic formula. So let me kind of set it up. 0 is equal to -5t squared plus 17.32t plus 2. Okay, we should all know that A is the one with the t squared, B is the one with just t, and C is constant. Then we should know negative b plus or minus b squared minus 4ac over 2a is the formula for a quadratic formula. Hopefully you guys just have a graphic calculator so you can just plug these things in. But let's see how far we get. So negative b, negative 17.32 plus or minus b squared, which is going to be 17.32 squared, minus 4a, which is -5, c, which is 2, divided by 2, -5. And let's see what the time we get is. I'm going to put this all into my calculator in one shot, but try to take your time with it. 32 squared plus, what is this, 20 times 2, so that's plus 40. Square root of that, 18.43. And let's see, we're going to want this to be negative because, we want a positive time. So we're going to get a positive time and a negative time. So we want the answer to be a positive time. So we're going to do plus 17.32 divided by 10. And we get 3.58 seconds. Okay. And that's at 10 meters per second squared. Of course, if it was 9.8, it'd take a little bit longer. So this is probably the answer that I'm looking for. 3.64. That's if you use 9.8. Okay. All right. Let's move on a bit. All right. So a dart fires at an angle of 45 degrees, and a dart reaches a maximum height of 1 meter. If the dart were fired straight up into the air along the vertical, what height would the dart reach? Okay, so a little bit difficult. So we see a dart is fired at 45 degrees, and then it reaches a height of 1 meter. Now we want to know, okay, and let's see what we know about this. Okay. Ax equals 0, ay equals -10. Displacement of the y, let's call that 1 meter. And we know when it reaches 1 meter, the v final in the y is 0. Okay. So then we could figure out what v initial in the y is. Okay. So v initial in the y, whoops, that's not how you find v initial in the y. So we have 4 pieces of information. So now we could do v final y squared is equal to v initial y squared plus 2a change in y. So 0 is equal to v initial y squared plus 2a -10 change in y 1. So let me do some math. So this is going to be 20 square root of 20. That gives me 4.47. V initial y, 4.47 meters per second. What I should know now is that this part of the velocity is 4.47 meters per second. But let's figure out what this hypotenuse is, because that's how much it's shot out with. So I'm going to do 4.47 divided by sine of 45. And that gives me 6.32. So I know initial velocity is 6.32 meters per second. So knowing that piece of information, if I shot this straight up at 6.32 meters per second, let's see what the highest point is. Okay. So what do I know? Initial velocity 6.32. What I know is the highest point, the final velocity is 0. I know acceleration of y is -10. And then I'm looking for what it is when it reaches the final velocity of 0, what is the displacement? So vfy squared is equal to v initial y squared plus 2a change in y. It's going to be 0 is equal to 6.32 squared plus 2 negative 10 change in y. Change in y is equal to, hold on, 6.32 squared divided by 20. 2 meters. Okay. 2 meters. All right, let's look at this problem. At a certain instant, a student is on the ground, okay, and sees a box falling with the speed v1, okay, at an angle with the vertical, okay. So angle with the vertical, got it? To a pilot flying horizontally at a constant speed, it appears to be falling with a vertical velocity v2. Okay, with what speed of the what is the speed of the pilot relative to the ground? Okay, so what we should know is if this pilot here sees this sees the box only going vertically down, what that means is the velocity of this box, let's just call that the vx, is the same as the velocity of the pilot. Okay, so these two are the same. And if those two are the same, what we should be able to find out is to a pilot flying horizontally, it appears to be falling vertically with speed 2. So that means this right here is going to be v2, because even when he's traveling like this, he's not going to see this vertical motion. All he's seeing is this vertical motion, which is v2. So we're trying to figure out what this vx is, because if we can figure out what this vx is, that's what we know is the same as the pilot's motion. So let's just do some Pythagorean theorem. What we should know is v1 squared is equal to v2 squared plus the vx squared. Okay? So if we're just trying to isolate vx, we should know that v1 squared minus v2 squared is equal to vx squared. So get rid of that by doing square root, and then we get rid of this. So v1 squared minus v2 squared. Okay? All right, last one. On level ground, what angle must a student throw a ball in order to achieve its maximum distance? We should know on level ground, the furthest something is ever going to go is if it's launched at 45 degrees with no air resistance. All right, guys. Thanks for watching.